All right, so welcome to our session. This is Automating Model Lifecycle Orchestration with Jenkins. I am Liam Newman, and this is not Conrado Miranda. Conrado got a cold and had to stay home, so instead we have Manasi Vartak. Vartak, is that it?
We'll get to it.
Matters to me. Who is our CEO, joining me on the stage here. Little background, I am a Jenkins pipeline engineer. I've worked on Jenkins for many, many years, worked with Jenkins and then on Jenkins at CloudBees before this, helped implement parts of the Jenkins declarative pipeline, and am a longtime CI/CD DevOps evangelist. Marcy?
All right. Hey, everyone. Thanks for being here. As Liam mentioned, I am not Conrado. I can try to be like him. My name is Manasi Vartak. I'm the founder and CEO of Verda. I also have a technical background, did my PhD in databases at MIT, and built one of the first open source model management systems called ModelDB that then evolved into what we do at Verda. So I'll be filling in for Conrado and filling in the ML and AI bits in our talk today.
What we're going to go over today is the context, the software lifecycle. Then we'll talk about CI, CD, DevOps, how Jenkins works with that, and then we'll give you some interesting examples that we've seen a lot in our work so far, and what those look like in Jenkins for some of the simpler ones. So before I go on, how many people here are consider themselves or have the title like data scientist? All right. A software engineer? Okay, roughly even split. Okay, good. Right. So for the software engineers, it's going to be kind of like, oh, I know this already. Data scientists, you probably have seen this as well, but just this is our bread and butter. You have the software development lifecycle. You go from analysis to UX, UI design, implementation, testing that thing, deploying it into production, and then maintaining that in production, and then you start all over again with a new set of features and whatever else, and improvements and fixes, right? And as we've all encountered, the later in that cycle you go, the more expensive it is to fix. Interesting point, this graph, that information has never been like studied or proven in an actual study. All the people citing this graph, they point, see it, there it is. It's like, yeah, it's never actually been measured. But we all have felt the pain. If nothing else, this is a graph of pain, if not time. As the later in the cycle, the more painful it is to fix problems. And CI, CD, DevOps, all of these things are designed to try and move the finding of problems and the fixing them further to the left in that process, so there's less pain and more effective and faster delivering of features to customers. So let's just get the terminology out of the way. Continuous integration is automated build and test, run in a pipeline on every change before it's merged. So that lets software engineers work on branches, work on their own little environments, and say, okay, this is ready. Someone reviews it, goes in, it gets tested, run through an automated set of tests, and is sort of proven to not be on fire before it goes into the main line where everyone else has to deal with it. Continuous delivery takes that, and then on top of that says, for every commit, every time something goes into mainline, we're going to generate a set of artifacts and deliver those so that we can use them in dev environments or staging internally. And then continuous deployment builds on that and says we're going to take those artifacts that we've tested in a dev environment or in staging, and we're going to use those, and we're going to deploy those to production in an automated fashion. Finally, you take off the end of that scale, you say, what would it look like if you took those tools and the automation and that process and expanded that to also apply to the rest of the culture of your software team, so that not just the engineers, but the testers, that everyone involved in the process of delivering that particular component has a sense of ownership and is involved with improving the process and making it go more smoothly, more quickly, and providing value to customers. Jenkins, for those of you who haven't dealt with it before, is a general purpose automation tool. It arrived at the right time for the right thing and has a broad system of plugins and tons of functionality, a huge user base. Basically, any software you see today, almost certainly someone has run it through a Jenkins pipeline of some sort to produce it. It's everywhere. It allows you to coordinate actions on multiple machines so you can run things in parallel, and it's used for implementing CI/CD pipelines just about everywhere. This is a list of best practices. I'm not going to go into them right now. Basically, the point here is you want to automate your processes, commit early and often. You build the delivery, the continuous delivery point that we made was you build it once and then you promote that same artifact as you go. You want to automate and streamline your tests so that they run more and more often. So again, they can be run further and further left on that graph so that you know when things go wrong sooner. You want to have clean environments that you can reproduce as clean, so it's not just, oh yeah, that worked on my machine, but it's broken in production. You want to make sure CI/CD pipelines, the only way that you deploy to production, nobody just takes a USB drive and walks over to the servers anymore, right? You want to monitor and measure all the time and make everything a team effort. That's DevOps. So, with that, I'm going to hand that. How does this apply? We're going to take these and talk about how they apply to AI and machine learning.
Great. All right. So I'm a data scientist, more or less, by training, and have never had to write a Jenkins pipeline. And yet, as we build models and bring them to production, that seems to be the requirement. And there's a few reasons for this. A model, if you think about it, it starts off as being data. You're doing feature engineering. Then you're training the model. It comes in the realm of models. And then you package it, and it becomes software. So it needs to live in these realms of data, model, and software at the same time. And what that means for CI/CD is ultimately your model will be used as a piece of software. It will call other web services. Other web services will call it. You want to have the same logging, monitoring that you would expect from a piece or component of software. And therefore, it needs to be part of a CI/CD pipeline. But this is hard. And there's a few different reasons for that. Big picture, data science is probably where software was 20 years ago. Few different reasons for that. One is missing tools or infrastructure. We're just begun to version our models, for instance. The skill sets that data scientists have are often different from software engineers. And so the training or tools that one is exposed to tend to be very different. And so what we found in our work helping lots of teams bring models to production is putting in robust CI/CD processes can help them go faster and also get there safely. So what we're going to do for the rest of this talk is to talk through a few examples of what pipelines we have helped customers build and we have seen built in production. I'll walk through the high-level workflow. Liam is going to show some Jenkins snippets so you can make them concrete. And hopefully that gives you a sense of what you can do when you go back to your day jobs. All right, so let's get right to it. The first one is that we see very frequently is testing ML code. It's super hard to figure out how to test a model, but in principle it can be done. Here, what we see most frequently is your code is being committed to GitHub. Every time that you commit to mainline, there's a webhook that's triggering a Jenkins pipeline. A Jenkins pipeline within it is going to have multiple steps. Typically, it's going to do unit tests or ML-specific tests. These take the form of giving the model data that it has seen before, and you know what the output should be, making sure that the outputs are within those parameters, giving it, obviously null values or outlier values, seeing what comes out of it. There's also code surrounding the model. That's just your regular, say, web services code. And you might want to do unit tests on it or integration tests. And what this helps you do is sanity check your model before it goes into the wild and other people start using it. So we'll take a look at what that looks in Jenkins now.
So Let's see, there we go. Have to exit out and flip over here. There we go. So,
Can you guys?
oh yeah, right, sorry. That looks good, yeah? Okay. One more? Yeah, that's the rule. The point at which you say, oh, that's too big, that's the right size. So this is the pipeline code for the graph you just saw. As you can see, it's pretty small. A lot of this is because Jenkins provides a set of plugins that do a lot of the work for you. It will listen for hooks from GitHub. You set up your GitHub with a webhook pointed at your Jenkins, and then you create the job, and Jenkins will sit and listen automatically. And when the job gets kicked off, you specify an agent, a Jenkins agent for it to run on, and it will, as part of the start of that, it will check out that code, and then run a set of stages which each have a set of steps in them, and return the result of those steps, and will automatically tell GitHub at the end of this whether or not that pipeline succeeded. In this case, I've made a couple of examples, just some echo statements to say, hey, here's what we're doing, and also shown that you can run shell scripts, you can run Python, you can run Groovy. There are plugins for doing any number of different commands that allow you to go from there to use your command line tool to run your tests, run your smoke tests, run whatever other components you want. Another example of one of the plugins from Jenkins is they have a Kubernetes plugin. So if you are running in an environment that you're using Kubernetes, you can use an agent setup that will, you can define a pod YAML for your Kubernetes that you want to run on, and then run your integration tests and other ML smoke tests in specific containers on that pod. And finally, you see this as stages here. These are the set of stages that's going to run. Changing that to actually run, that runs in parallel, in serial. And if you want to change that to run in parallel, you change stages to parallel, and off you go, and it'll run all the stages within there in parallel, giving you even faster results. All right. Going back here.
Awesome. So that was an example of testing your model. The other part that we've seen done very frequently through Jenkins is verifying your data pipeline. And this comes in different flavors. In this one, we're using a Airflow job to actually run the pipeline, for instance. And it's going to give you a thumbs up or thumbs down, depending on whether the data pipeline succeeded or not. You can also think about using a similar workflow if you want to automate your training, for instance, and you want to have your training, go ahead, you're going to do some hyperparameter searching and get the best ones and report back in a status. So in the next example, we show how a very similar pipeline can be used so that you're doing training and you're reporting your metrics back there.
So from here, as you noticed in the slide there, we were using Airflow. Again, Jenkins has a number of, the Jenkins pipeline is actually a Groovy syntax, which lets you add and write your own components to do whatever you need done. So in this case, I actually went out and found someone who had written a script that I can load up inside of my Jenkins pipeline to trigger an Airflow job. It's a DAG, right? Trigger an Airflow DAG, and then wait for it to complete, and again, report back success or failure automatically. And then there's let me see if I've got the next one there. I didn't quite get to this. So then there's a GitHub notify step that I can use here in the post section of when something succeeds or fails, and load up data from the local environment and send that back to GitHub. That's with the quality matrix.
Yep.
Okay.
All right, great. So that was maybe, let's call it the testing of the model, and maybe you're verifying that the data integrity still holds. There's a few different ways in which these models do come to production, and we'll talk about a few of those templates next. This is one that we see fairly frequently where there is a different job that's actually training your models. So every night there's an Airflow job that's running and you're creating an artifact, which is usually your trained model, and you're logging that artifact to a system. On the other hand, you have your code that is actually going to read the artifact and then run it in some fashion. That lives in your GitHub repo. And what we see most frequently is Airflow runs on its own. There's pushing like the newest model every day. And every time that you commit to mainline, which is a serving code, then your Jenkins job is triggered. It's going to package the code with the latest model. It's going to run another Jenkins job to deploy it, and it's going to start running in your dev cluster. So this is separation of the code that's running the model and the model itself. You can also combine them in case they live in the same job and you're training and you're logging the model at the same time. Once a model is in production, there's usually not going to be a single cluster where you will run it. And in our experience, this is kind of where data scientist responsibilities sometimes end, and there's a ML engineer or production engineer that takes over. We think that more data scientists should be exposed to this. Usually when there's a change, you're going to deploy to your dev clusters. You're going to do your local testing, make sure your model doesn't break unexpectedly, all of those things. Once you've verified that, then it's going to staging. And the way to do that, again, is via Jenkins pipeline. You're going to run your end-to-end tests, your unit tests, your integration tests, whatever your regular software mandates in your team, and you're going to move it to staging. Staging is where typically we see both manual and automated smoke tests run, and it's not just your model, but it's a much more complex set of modules that are talking to each other and so on. That's what's going to happen in staging. There's going to be end-to-end testing, manual testing, and then depending on the schedule, for instance, you're going to move it to a production cluster. So at this point, typically we see like half a dozen different Jenkins pipelines that are going to get called here in order to take your model to production. Now, these can get arbitrarily complex depending on the type of company that you work at. So for instance, if you are a large enterprise, then vulnerabilities in your model containers are going to be significant source of headaches for your IT. And so it's going to include a vulnerability scanning within your Jenkins pipeline. That's where you're going to use an ECR, twist lock, you name it, scanner in order to scan your models. And then depending on the type of vulnerabilities, you decide whether to promote or not. This also goes to approvals, like you need to have a ServiceNow ticket, and someone needs to approve said ServiceNow ticket. Or you have a governance team, and the governance team needs to review what model is being used. Is it using data that it's supposed to use? Is it within the realms of their expectation? And also responsible AI practices often come in there. And so depending on what your needs are, the Jenkins pipeline does need to be tailored for that. That's why it's hard to give like, here's the one Jenkins pipeline for all of your needs. It really depends on what you're trying to string together. So I think you're up next.
Yeah. For each of those things, by the way, the components are sort of mix and match. You saw earlier, like you saw you saw running your pipeline in a particular pod. You can use that again for when you're running in staging or for when you're deploying to production. Just FYI, they're very much, you can build them up as you go. So let's go back for a second. Data scientists, raise your hand. Again, okay, cool. Engineers? Yeah. So whoever you are that you raised your hand, look at the people who aren't raising their hand at that moment, and those are the people you need to talk to, because they have knowledge that you don't have and have experience in this realm that you don't. DevOps folks want everyone at the company to do good processes and to participate and own the software lifecycle end to end. DS and ML live in their own land a lot of the time, and they need to become part of the developer ecosystem at the company. And by doing so, that will help everyone produce value for their customers faster. A lot of the orchestrations problems that you see in data science and machine learning areas have already been solved in software. And so ask them about it. Find your engineers and talk to them about it over coffee, because they probably have some ideas. And of course, you can also come talk to us. We know what we're doing, and you should reach out to us and talk to us about it at verta.ai. Thank you. Questions?
I think someone is getting a microphone, yeah.
Comment on the automated Jenkins pipeline and how does you factor in the data drift issue or challenges?
The which? Sorry. There we go.
Sorry.
Thank you. I'm more interested to learn about how do you factor in the data drift into the automated Jenkins
data drift.
pipeline?
Yep.
Thank you.
Yep, I can take that one. So typically what we've seen is the data drift depends on the data. The data systems are going to be separate from where your model is deployed. What we've seen to be most effective is two things. Either you have a job within the Jenkins pipeline that's going to do the drift comparison, and then you take actions such as retraining based on it. The other option is to use a model monitoring tool that actually will alert you proactively, where you don't need to wait for a Jenkins pipeline to run, and then you can take an action accordingly.
Hi, everyone. This is Rafael from Slalom Consulting. Thanks a lot for this talk. This is amazing. I've done a lot of DevOps myself. So I'm 100% convinced of the return on investment. My question is this. What is the size of your team that benefits from these processes and these pipelines? And could you quantify or give me an order of magnitude of the yearly cost in terms of paying the DevOps engineer, the Jenkins infrastructure and whatnot? Just trying to get a sense for what's the investment and how many people does that benefit? And I personally have no doubt on the return on investment that it's a positive thing. Thank you.
So as a DevOps advocate, my opinion is that it benefits every size of team, and that if you use the tooling and start from that philosophy, and stay there from the beginning, then it helps. That should want to stay, no matter what the size of your team. It sounds like what you're asking might be less about that and more like, when should we get one person that's going to be the DevOps engineer, or?
No, not necessarily. Good. I'm wondering, actually two numbers. What's the number of people that benefit from these pipelines at Verta? And how much does that cost you per year? And you don't have to give me the actual numbers. I'm just looking for orders of magnitude, because I'm sure it's complicated for you to share these numbers.
Yeah, let me answer it in terms of, we think about it in terms of models as opposed to people. You can have two people and you're running very business critical models, and maybe you have 5. I think if you have only one model or 2 models, a bunch of these things might be overkill unless those are completely running your business. I would say the sweet spot we found is half a dozen, like between 5 or 6. That's when you're repeating yourself enough number of times that you want to invest in these types of tools.
This goes back to the machine learning being the model being an artisanal kind of thing.
Yes.
And at a small enough size, you don't need to repeat it. But once you start doing it, like you said, it doesn't. So that's the point at which you.
Also, just off the back of that, from I suppose a Databricks perspective, we've got a BVA team that can support you in that. So we break it down into use case, productivity, and infrastructure, potential savings around that. So it might be a case of we can sync on, providing some statistics that you can go ahead and share with your customers as well. So happy to sync up after. Perfect. Any other questions?
There's one more there.
Back.
Oh, sorry. You're up. Yeah.
Hi. So thank you for the intro about introducing the software development lifecycle to data science practitioners. I'm interested in knowing if you have approaches or tools, solutions that have gained traction with data scientists for being able to, say, properly track the data lineage or versioning on the data sets that they use to train models? Because a lot of them, out of habit, will do this in, say, just a notebook or create an artifact. They put some arbitrary object store and host it there. And this all ends up existing outside of like a standard software development process. What have you found is effective in gaining traction in the data science community for this?
Yeah, I can provide my perspective. I'm sure Databricks has a different one. So I think it's a losing proposition to try to limit what data scientists want to do. We divide the life cycle into a build side and a run side. On the build side, let the data scientists have full freedom, creativity in how they want to build models. When it comes to production, that's when you want to start imposing those restrictions. What we found to work really well is having a sort of narrow middle. We call it kind of model catalog. Think about data catalogs, where unless you have a certain number of requirements on your model, like what data was it trained on? Is your code checked into Git? Do you have a Jenkins job in order to take it to production? So you don't need to standardize and police all the work that's going on in data science. You only do it when a model is going into production. And in terms of what have we found to track data versions, I think the answer varies. Sometimes you are querying a direct database. Sometimes you are talking about a blob store, or certain databases also allow time travel. And so in our experience, the answer depends on where the data lives. The thing that we found consistently is impose the controls when you're going to production. Don't worry about what's going on in the messy, sort of creative parts of data science.
And I guess I would add to that, from a DevOps perspective, you don't have to boil the ocean. You can start with providing, you can look at this from the other side maybe to say, what value can you provide to your data scientists, right? Not how do you stop them from doing X, Y, or Z, but like, oh, you want to create a notebook, great, can you just check it into Git? Just do that, and then we can go from there. And okay, well, you're checking it to Git, so now the next time you like, oh, I forgot that piece, you can go back and find it now, right? So, and then you can phrase this in terms of incentive as opposed to restriction.